Hello, this is Kiran Kamble, and today I'm going to talk about part 2 of the Statistical Conclusion Validity and Internal Validity chapter 2. So let's start. In the previous sections, we talked about statistical conclusion validity. Let us now see what are the threats to statistical conclusion validity. Table 2.2 in the textbook lists 9 threats to statistical conclusion validity. But before discussing those, let us quickly revise what statistical conclusion validity is. So, put simply, it is the degree to which conclusions about a relationship among variables, cause and effect, based on data, are correct and reasonable. It's concerned with statistical covariance between the cause and effect. Now let us look at the threats. Threat number one to SCV, that is statistical conclusion validity, is low statistical power. It occurs when uh, the power of the study is low due to small sample size, and it is a type 2 error, which is accepting null hypothesis when it is false. The suggested remedial measures are using variable that is correlated with the outcome for matching, stratifying, and blocking. But one has to note that matching with small units is useless, so the sample size has to be adequate. Threat number two is violated assumptions of test statistics. This leads to incorrect inferences about covariance in a cause and effect relationship, and there is a chance of type 1 or even type 2 error. For example, violation of independence when the study units are members of a family or persons from the same neighborhood, etc. And it leads to standard error estimation bias. The proposed remedy is to ensure that the study units are separated by space and time, and there are also statistical methods that are used to counter such violations after the fact, that is, after the study during analysis. Third threat is phishing and error rate problem, which is repeated tests or multiple investigators analyzing the same data sets, increasing the probability of type 1 error. The solution is using statistical methods like Bonferrone's correction, which adjusts p-value to correct the increased risk of type 1 error. Threat number 4 is unreliability of measures. Lack of reliability of measures also minimizes a bivariate relationship significance. And in a multivariate relationship, the, the effect of unreliability cannot be predicted. The solution commonly used are increasing the number of measurements, enhancing measurement quality, and statistical methods like latent variable modeling and several observed measures. Threat number 5 is restriction of range, which is floor and ceiling effect due to closely restricted values of treatment or outcome, the variables that I use. Such restriction reduces power and leads to type 2 error. Remedy is usually preempting such restriction by pilot testing measures and selection procedures. So the measures to be used and the selection procedures are pilot tested before actual study, and also using item response theory analysis to correct any restriction problem. Now, threat number 6 is unreliable treatment implementation, which is non-compliance to standards and protocols laid out for the study implementation, which affects effect size estimation and, for example, differences in treatment within units and across sites. Although it should be noted that such variation can be desirable based on study particulars. Sometimes it is aimed for, and but when it is not desired, when it is not wanted, the solution can be to understand first how different components of a treatment affect the outcome and improve for monitoring and implementation, improving the implementation of that particular treatment execution. Threat number 7 is erroneous variances in experimental setting, which causes inflation in error, resulting in difficulty detecting any effect. For example, factors not concerned with the experiment but potentially affect the result, such as noise, changes in temperature. Remedial measures can be during the experiment to negate the effect of such variances, or after the study during statistical analysis by using appropriate statistical methods. But the most important thing is anticipating such erroneous variances and then try to tackle them or preempt them. Threat number 8 is heterogeneity of units. Now, due to increased variance and resulting greater standard deviation, the relationship between treatment and outcome will be blurred when the units are too heterogeneous. For example, ignoring certain characteristics of units that interact with the treatment outcome relationship may occur when the heterogeneity of units is present. The best solution is to select homogeneous units, which is obviously the most logical one, but that will affect the external validity. Hence, identifying, measuring, and blocking such characteristics is the more practical solution. For example, using within participant design. Threat number 9 is inaccurate effect size estimation, which is under or overestimation, for example, which commonly occurs due to presence of outliers in a study or in a sample. The solution is usually to use odds ratio or alternate effect size estimation during the analysis. So those were the threats to statistical conclusion validity. Pretty dense to understand, but I hope it was at least a little bit more clearer. Let's move on. Now, the textbook also defines internal validity, which we have seen earlier, but let's see what internal validity means again. It is the degree to which an inference of a causal relationship between a treatment and an outcome can be made based on an observed covariance between these two variables, the treatment and the outcome, while eliminating all alternate explanations for the outcome. Now, to support such causal inference, three conditions have been specified by John Stuart Mill that we saw in the last chapter. Now, to ensure these three conditions are met, researchers have to ensure that for a causal relationship between a variable x, which is say a treatment, and variable y, which is an outcome, to prove that a researcher should show that y follows x, that is the outcome follows the treatment. Change in x will lead to it is leading to a change in y, and there is no other explanation for the change in y apart from x. Now, the textbook also mentions different terminology used for internal validity by Campbell, which is local, molar, causal validity. Let's look what it is. So, local, molar, causal validity. Local in that term implies that the causal conclusions are limited to the unit, treatments, observations, and setting, the UTOS of Cronbach. So it's local. They are limited to those settings in a study. Molar relates to the complexity of a treatment. So a treatment is never a single entity. It is a combination of various components. Every treatment has various components. That's why molar. And causal validity denotes internal validity, which talks about causal inferences. Now, let's move on to the next slide. We've seen what internal validity is. Now, let's look at what are the threats to internal validity. The first threat the textbook describes is ambiguous temporal precedence. When there is a confusion about the chronology and role of variables, it is called ambiguous temporal precedence, which is like proving whether variable X occurred, that is treatment occurred before Y, that is the outcome, which happens especially in a longitudinal or bidirectional studies, and it's difficult to really prove in real life. Also, X occurring before Y does not actually prove causation. Um, Solutions can be to conduct separate experiments before the actual study to see, you know, the temporal sequence to see if X comes before Y or vice versa, and to also ascertain if there is a bidirectional causation. So X causes Y, but Y also causes X. So those are the solutions. Second threat is selection. Selection bias may lead to erroneous effects, as we have seen many times, attributed to treatment as the unit have special interest. So the effect may be wrongly attributed to the treatment uh, because the because of selection bias, the units have a special interest in the outcome. Selection bias is very pervasive in quasi experiments, and the remedy can be to assign self selected units to different groups so that it minimizes the selection bias, error caused by selection bias. And ensuring strict randomization in experimental studies is the most important. Threat number three is history. This is a common threat occurrence in public health practice and research as well. Because historical, there is hardly any implementation or program area where any program idea has not been implemented. Uh, the programs do vary uh, with in their implementation strategies, but most of the programs have been implemented across areas. So it is very difficult to tease out the effect of a new experiment or a research or a study. Now, the solution can be to have ensure simultaneous treatment and control of matched groups, a very closely controlled experiment, or while doing a study when we know that there is a history of past research or similar studies, then we have to take them into account and control for those past effects. Threat number four, excuse me, is maturation. These are naturally occurring events such as disasters, economic growth, slowdown, aging, social factors, and other social events, which may cause effects that mimic those caused by the treatment. A solution to maturation threat is to ensure that selected units are from same environment or state, that is age, location, institution, etc., to minimize the maturation threat. Threat number five is regression. It occurs when extreme values are selected either inadvertently or purposely. Like sometimes the study looks at specific populations, so we select that specific sample from that specific groups which will have extreme values in some measures. But having extreme values in one measure may the same units may have lower values in other measures. So this will, as you can see, cause incorrect effect uh, depictions or the outcomes, and which will dilute the study. So, and these usually are also seen in pre and post tests in longitudinal studies in repeated measures, because during one measure the same unit may have extreme values, but during the repeat measure it will have lower values. The remedy is to select, create a group of these extreme value, there are several remedies. One can be to create a group of these extreme value units and then randomly select from them, or to take not rely on one measure but to take several measures and then average them out. So this will then reduce the effect of regression. Threat number 6 is attrition, which we've seen earlier, is also a loss of units in a study, which leads to attrition and also creates artificial selection bias, which will obviously have an adverse effect on the outcome. So, for example, when a wrong therapy is used in counseling, which will lead to attrition. Now, this is not due to any problem with the participants, but because of problem with the treatment. Solutions can be difficult and are hardly foolproof, but may entail offering incentives, careful tracking, and trying to retain participants by all possible legal means to reduce the threat of attrition. Threat number 7 is testing. It's a fairly common cause of concern in research and occurs due to familiarity and specific reactivity to a test due to repeated exposure to it. So, taking a test repeatedly, one would have a specific enhanced effect outcome to that test. There is a design called Solomon 4 group design that can help identify the testing effects. Remedy can be using the technique of item response theory to calibrate each item in a test and then develop uh, remedies, further specific remedies to reduce the threat of testing. Now, threat number 8 is instrumentation, which is a naturally occurring change in the instrument or the measure that is used in study, and which then obviously would adversely affect the outcome of the study, the effect because of the cause. It is usually seen in repeated measures or longitudinal studies when the instrument or the measures that are used may naturally change or change due to repeated use. So the solution is to avoid any change in instrument during the study, which rarely happens. But the most practical solution would be to keep repeatedly checking the instrument or the measure to ensure that it is reliable at different times and reliably measuring what needs to be measured. Threat number 9, the last threat, is additive and interactive effects of various threats. So all these different threats never occur in silos. Threats will always occur in one, two, or in combinations, and they will have additive or interactive effect to adversely then influence the outcome of the study. It is usually very difficult to estimate different threats in a study. It needs diligence and careful, painfully systematic approach. But the solution is to carefully identify each threat and then apply remedial measures specific to each threat, but at the same time also considering the other threats that are available or present in the study. So those were the threats for internal validity. Let's move on. Now, the book also talks about, clarifies some concepts around internal validity and random assignment. So, how can random assignment improve internal validity? Randomization improves internal validity by eliminating selection bias, by reducing the plausibility of other threats, such as maturation, pretesting, testing, and instrumentation. So these threats are minimized, and that's how randomization improves internal validity. Randomization is also believed, and as it has been explained in the textbook, it causes two issues with inferences about causation. First is differential attrition, which causes differences in outcome as we've seen before. It is usually corrected by retention and tracking techniques. And the second situation that occurs due to randomization in making causal inferences is anticipating, sometimes an experimenter, while anticipating a response burden, that is fatigue in the participants due to lengthy questionnaire or instrument. At such time, the experimenter would try to preempt such response burden by applying the pretest only to the treatment group. So that is when the second issue that can occur. Now, the solution would be to ensure equivalence of testing procedures across groups and to ensure that the differences in applying any procedures to the two groups, treatment and control groups, are minimized as much as possible, and there is equality in application of all the procedures. Now, the book also describes certain internal validity threats in terms of quasi experiments. The book specifically mentions that quasi experiments are more prone to threats of internal validity and also lays out suggestions to counter the threat. The suggestions can be grouped into two categories. First option is to modify study designs without altering the research question. For example, reducing regression by avoiding units with extreme scores, minimizing history threat effect by experimental isolation to the extent possible, reducing attrition by retention and tracking. Second category of options suggested by the book to reduce internal validity for quasi experiments is to identify all the threats and tackle them individually using appropriate and applicable qualitative and quantitative techniques. So that was about internal validity and random assignment. Let's move on to the next topic. That is, now we've seen in this chapter what statistical conclusion validity is and internal validity is. Now let's see what these two mean together. The book states that statistical conclusion validity and internal validity are very closely related, and we've seen as we've gone through both the validities and also their threats, which quite often are similar. Now, both these validities are together have some things in common. They both are concerned with study operations rather than and not with the constructs on which the study is based. So they are mainly concerned with the operationalization of the study and not the construct. Second aspect is both are concerned with the relationship between the treatment and the outcome, the cause-effect relationship. Individually, statistical conclusion validity is concerned with errors in assessing statistical covariation between cause and effect. That's what statistical conclusion validity is all about. While internal validity is concerned with causal inferencing. Now, the book also states that in a quantitative experiment, uh, which one is better, internal validity or statistical conclusion validity? From what is explained in the book, and I agree to it, is uh, statistical conclusion validity seems to have an upper hand on as compared to internal validity when it comes to quantitative experiments. Now, Although statistical covariation does not prove causation, and statistical covariation is the important element of statistical conclusion validity, it doesn't prove causation. But in a quantitative experiment or a randomized experiment, statistical errors would still lead to errors in estimating effect sizes and deriving significance. Conclusion of significance would also be adversely affected. And both these would eventually affect the internal validity. And that is why statistical conclusion validity do not directly influencing causation, does influence internal validity, and so has is more important as per the book and in context of quantitative experiments. So that was about statistical conclusion validity and internal validity. Till next time, bye.